Welcome, Study Buddy. I am absolutely thrilled to have you here for this explainer, where we are going to welcome Topic 3 on Lesson 10, Controlling Infinite While Loops. We're cracking open Coach Timothy's playbook today to take our understanding of Python loops a massive step further. We aren't just going to talk about how to write code, We're looking at this like a true coach's playbook for mastering Python control flow. It's all about taking charge of your programs. So get comfortable, keep your notebook nearby, and let's get ready to experiment. Okay, let's dive into this. Here is our practice schedule for today. First, a welcome to Topic 3. Second, we'll explore the infinite loop phenomenon. Third, accidental versus intentional loops. Fourth, our escape hatch, the break statement. And finally, the 5 coach questions. Starting things off with Section 1, welcome to Topic 3. Now, before we write a single line of code, here's a quick reminder from Coach Timothy. Moving from writing basic loops to actually controlling program flow, that is a major step. And hey, it is perfectly okay if it feels a bit confusing at first. Making mistakes is literally just part of becoming a programmer. To help us navigate that, we're going to rely heavily on our study group learning process. We won't just memorize definitions today, because let's be real, that's not how true learning happens. Instead, we'll actively follow these steps. First, we understand the concept. Then we trace examples and predict what the code will do. Next, we code and write our own programs. After that, we test different inputs, debug any problems we run into, and finally, improve. With every single attempt, you're going to get better and better at controlling your code. All right, moving right along to Section 2, the infinite loop phenomenon. So, you probably already know that a standard loop continues as long as its condition evaluates to true, right? And it naturally stops when it becomes false. But what happens when that condition never becomes false? Well, that exact scenario creates what we call an infinite while loop. Simply put, an infinite while loop is a loop that continues running indefinitely because it has absolutely no natural stopping point whatsoever. It just keeps going and going and going. And this brilliantly illustrates exactly what we're talking about. Think about a line of code like while true, print Python is running. Because the Boolean value true is always fundamentally true, this loop has 0 natural stopping points. If you run this, your program will just continue printing that phrase forever. Fun fact for you, if you accidentally do this in a professional cloud environment, it will just keep running and literally billing your credit card until the next morning. Your program basically appears totally stuck. Which leads us perfectly into Section 3, accidental versus intentional loops. Now, when beginners see a program stuck like that, panic usually sets in. But here's the secret. An infinite loop isn't always a bug. We actually have a clear divide here. On one side, you've got accidental loops. This happens when a programmer just forgets to update a variable that controls the loop, causing the whole thing to get stuck. You'll definitely have to manually interrupt those in your terminal. But on the flip side, we have intentional loops. These are incredibly powerful features that we actively want to use when we don't know beforehand exactly how many times a program needs to run. They are designed entirely on purpose. Because intentional infinite loops are so incredibly common in professional coding, there is a golden rule you've just got to memorize right now. Whenever you see a while true statement in your code, this absolutely essential question has to pop into your mind instantly. Where does this loop stop? If you check the code and there's no mechanism to terminate it, you need to step back and examine it carefully, because you might just have an accidental loop on your hands. That brings us to Section 4, the break statement escape. So, if we're using infinite loops intentionally, we obviously need a reliable way out. And the hero of our playbook? The break statement. The break statement allows us to exit a loop immediately when a very particular condition is met. This is exactly how we intentionally terminate a loop. For instance, Coach Timothy outlines a message collector program where you might continually ask a user for input. We intentionally create an infinite loop there because we have absolutely no idea how many messages they want to type. But we program it so that if the user enters the letter Q, the break statement is triggered, and boom, the loop terminates instantly. And listen, this isn't just academic theory. Think about real-world industry applications, command line apps, data entry systems, interactive tools, and automated processes. Every single one of these relies on this exact logic to keep working continuously until a user, a system, or an explicit command tells them to stop. The real game changer here is knowing exactly when an infinite loop is appropriate and how to provide a rock-solid, reliable way to stop it using that break statement. All right, let's wrap things up with Section 5, the 5 coach questions. Coach Timothy strongly advises keeping 5 essential questions right beside you as you work on your hands-on exercises. Question number 1. What condition controls my loop? This is all about building the habit of always identifying the driving force of your code. Before you write anything else, you've got to know exactly what Boolean condition is dictating whether your loop runs or skips. Question number 2. Can that condition ever become false? You need to actively check your logic for a natural stopping point. If the condition is literally just the word true, well, then the answer is no, it will never naturally become false. Which leads us directly to the next critical check. So the crucial point is right here in question 3. If I use while true, where is my break? This firmly links the concept of while true with the absolute necessity of a break statement. You literally cannot safely have one without the other when you're designing intentional programs. Moving on to question number 4. What exact situation causes break to execute? You need to deeply understand the exact trigger for stopping. Is it a user entering a queue, or maybe a file size exceeding a certain limit? Whatever it is, you must define that exact trigger clearly, usually in an if statement right before your break. And finally, question number 5. What happens after the loop ends? This one makes sure you're thinking about the overall program flow once the loop is successfully escaped. Remember, your program doesn't just cease to exist. It moves right on to the next line of code outside that loop. You have to plan for what that next step is going to be. When you start using those 5 questions, you successfully transition away from that beginner panic of, oh no, how do I stop my program after it goes wrong? Instead, your primary goal becomes answering this central question. How do I design my loop so I know exactly how it will stop? Now that is a professional mindset. It really proves how far your understanding has evolved. You're no longer just reacting to code, you are architecting it. Coach Timothy leaves us with one incredibly empowering thought to end this explainer. Learn how to make infinite loops work for us, not against us. You now know how to architect code that runs forever, and exactly how to escape it. But before you open up your Python environment and start experimenting, I want you to ask yourself this one provocative question. If your code literally has the power to run continuously until the end of time, what exactly are you going to build with it? Get out there and start coding.